Yeah. So my project is based on the recent Kilauea eruption that just happened in May of 2018. I'm actually originally from Hawaii, so this kind of hit close to home. Yeah, so here we go. So just as a disclosure, the media kind of blew this up a little bit. People still went and played golf as the volcano was erupting and causing a lot of damage. But there was one really important thing, and I think that was the pollution, which is the data source I'll get into further. However, I did look at satellite data, in which I was studying the NDVI vegetation indexes and how vegetation would change from the pre-eruption to the post-eruption. So my Landsat data, as you can tell, looks cloudy, but not only cloudy, it looks a little bit puzzled. And this is because I had to mosaic all of the images together. There wasn't one clear image that encompassed the entire scene that I was looking at. So from both the pre and the post eruption, I have two different dates in order to get the entire image. In addition to the fact that there's a lot of clouds, however, the resolution is really good. So I wanted to consider it as one of my data sources. So this is my NDVI calculations for the pre and the post. And this is my difference of NDVI. As you can tell, there was a loss of vegetation indicated by the numbers below 0. However, because there's so much cloud cover, the data had a high uncertainty level, and I wanted to compare it with a few other different data sources, which led me to MODIS data. However, I knew that there were a lot of clouds over Kilauea from my Landsat data. So looking at MODIS data, I was like, I don't know what I'm looking at. I don't know if it's clouds. I don't know if it's data. So I found pre-calculated NDVI data from MODIS and took that data and calculated my own difference of vegetation, which looks a bit all over the place. But that's because MODIS has a very low resolution and just creates a lot of confusion. However, there was indication that there was loss of vegetation. My last satellite imagery source was Aster, which had a really high resolution like Landsat, but again, finding a clear site was a little bit difficult. And I had to mosaic the images together, and then I found out that using Aster, you actually have to convert the radiance values to reflectance values to then calculate NDVI. So it was a huge learning process going through Aster for me. This is the DNDVI, the Aster data, which also shows a loss of vegetation. However, in addition to just vegetation changing, there was a huge, almost more impactful result when I looked at the pollution data. So the eruption did destroy a lot of land and deformed a lot of land and destroyed about 700 homes. Though some of those homes, it was just like their pool was destroyed. Like I said, the media kind of blew it out of the water. No pun intended. But the pollution was a huge impact. And I looked at sulfur dioxide pollution and particulate matter pollution, both of which are very detrimental to respiratory health and can cause heart attacks or even premature death in people that have respiratory issues pre-existing. So this is an image of why my data was so cloudy, which is actually a result of the sulfur dioxide that's emitted from the volcano when it erupts. When the sulfur dioxide reacts with the atmosphere, it creates this fog, which makes a lot of the island just blurry, which makes it really hard to calculate anything vegetation related. So this is the sulfur dioxide concentrations. The black line is the level of which sulfur dioxide levels should stay under for a healthy living environment. And there's a lot of values there that are above that line. So sulfur dioxide emissions, huge in Hawaii. The other pollutant, as I mentioned, was particulate matter at a size of 2.5 micrometers, which is the level of which it could get into your respiratory system and cause harmful effects. As I said, premature death, heart attacks, asthma, and etc. This is the line at about 35 micrometers at which it's unhealthy for humans to be exposed to. And as you can see, during the eruption, just after May, the levels are much higher. Very bad. So, in conclusion, Hawaii has a lot of cloud disturbance, especially during a volcano in the middle of the Pacific, with sulfur dioxide creating fog. So it makes it really hard to analyze volcanic destruction and impacts with just satellite imagery. So more data sources should be incorporated to really get the whole image of what the impacts were of a volcano. And this is something that I don't think the media really took on. They focused a lot on pictures and homes that were destroyed, but they didn't touch anything on pollution. Hawaii is often noticed as a place that's great for people with respiratory health and get sick often because it's so humid and it's great and it's tropical and the sun is always shining. But that's not always true because there's all of these pollutants that get spread not just over the Big Island, but across all islands. And another thing that I wanted to get to, but I didn't have the chance to, is I wanted to analyze SAR data to take a look at the digital elevation change of the land and see how that changed from pre and post eruption. But I think that would be another useful data set to incorporate in another volcanic study. And that's it.